Hi guys, in this video I will first show you some cool improvement to our Alexa, and then I also will show you what you have to fix. So far the test program for the Alexa just prints the line numbers and columns where a token was found, and also the token kind, the string representation of this token kind, and this was actually already a cool improvement. Now the big new feature will be that you will also see what characters were grouped into a token. And the changes to the test program look like that. You simply now have another parameter to this printf here. And now I will show you on the command line how this looks like when you run this program and what its limitations currently are. You see that this global variable token now has another member, val, and this member has another member, cstring. And cstring means that you have a zero terminated string. And the meaning of this member is that it's supposed to be a string with the characters that were grouped into the current token. And if we run the test program, it's already compiled, then I, for example, can type in ABC123, and then you see the Alexa found an identifier from the characters ABC, a decimal literal from the characters 1 to 3, and of course you could do this also for some hexadecimal literal like that. So kind of cool that we now see from what characters this token was grouped. What are the limitations if I type in some longer string ABC and so on? Then I get this annoying error message that this string is too long. Okay, so let me show you what I actually implemented and what you then have to fix. What I basically did is I implemented a simple string class in C that provides two methods, one method for setting a string to the empty string and another method for appending a character to a string. And this string class is used in Alexa, of course. And from this header file for this string class, you already see its limitation and why you got this error message on the command line when I tried to type in some strings that were obviously too long. We have here this hard-coded dimension for this array of characters. And I didn't even use a enum constant or a macro for this dimension, because later this will be anyway changed. Of course, we will use dynamic memory allocation for supporting arbitrary sizes of strings. Now let me show you how this implementation of the string class can be used in general, and then I will show you how it's currently used in Alexa. And then we will consider how to change the implementation of this string class. And ideally, this should be possible without changing the implementation in Alexa. So we should be able actually to improve the implementation of this string class without having effect to its interface. If you define a variable of this struct type, it means that this variable is somewhere in memory. So it has an address and a size. And actually, if we look at the details, it's a struct. So it has two members. The first member is simply a pointer. And after this member, we have this array of characters. That means this C string is simply an address, the address of the memory cell that comes after this pointer. And if you call this method clearString, it simply has the effect that this pointer, this member end, will point to the first element in this array of characters. And also this first character in this array will be initialized with 0. And that means now we have a 0 terminated string in this array of characters, if we use cstring as a pointer to the first character in this string. If you call this method append character to string, then you will basically do the following. You will first override the memory cell to which end was pointing with the character. Then you increment the pointer, and after that you write the 0. Then we have a string with one character, f, followed by the 0 byte. That means we have a string of length 1. And with that you can, for example, add two other characters like that. And that means now we have this string foo, 0 terminated. If you then call clearString again, you simply set back end to the first element in the array and initialize it with 0. And now we have again a 0 terminated string with length 0. And that means this is very fast to add characters and to set back a string to the empty string. But the limitation, of course, is that if the string is too long, it doesn't fit into this array of characters. And this method append character to string checks whether actually another character fits into this array. Okay, and now I want to show you how this is used in Alexa, and then we think about how to generalize things. In the header file of the Alexa, I simply added this member val to our token type, and that means now we have this member .val in token. In the implementation of the Alexa, I just made modifications to the getToken function. In this while loop here, I'm skipping the white spaces. That means after this while loop, I know that I found a token. That's why I'm setting here the token position to the current position of the character. And then I initialize the string to the empty string. And then when I pass different token kinds, each time before I consume the current character, I append it to this token val. And that's actually basically it. So that means basically you can search here for each call of next char, and before that you basically see that I append this character. So no big deal. Now let's look at this string class. So you already saw the header. Now let's look at the implementation, and this is kind of simple. When you clear the string, I first initialize this member end so that it's pointing to the first character of the string, and then I will initialize this with 0, this cell. That means I now have this empty string. And in this append character to string method, I first check whether another character fits into the string. And here I exploit that with this subtraction of these 2 pointers. I get the length of the string without the 0 that terminates the string. And that means the length of the string plus the 0 byte would be this difference plus 1. And now I have to check if another character would fit into this string. And with this size of, I get the current capacity of the string, the dimension of this array. And if this would not fit into the string, then I print this error message to standard error and I exit with exit code 1. If it fits into the string, then I override the character to which end points currently with C, and then I increment the pointer. And after that, I also write this 0 byte so that I always have a 0 terminated string each time I call append character. And actually I want to avoid empty lines in the end of a file. So that's it. That's the implementation of the string class currently. This will be the new interface for this string class. You see that the declarations for these methods haven't changed. What has changed is the declaration for this struct. CString is no longer an array, it's now also a pointer. And we have a new member, capacity, of type size t, which is the right type for representing dimensions of arrays. How should this class be used? We require that when you want to use an object of this class, a variable of this class, the capacity member should be 0 initialized. For us, it means that we actually do not have to change anything for that in the code of the Alexa, because there we use this object as a global variable, so it will be initialized. It's there an uninitialized global variable, so it will be 0 initialized. So that means we will have the following situation in memory, that this capacity is 0 and also the pointers are actually 0 pointers. Then we require that before you call this append method for appending a character, this clear method gets called first, which is what we do already anyway. And in this clear method, you will check whether you actually have a capacity unequal to 0. If this is not the case, you allocate some memory, some minimal size for a string that we want to provide. And we also change this capacity to this minimal capacity. Let's say this is 2. Then after this first call of clear string, we would have that we have allocated some memory, and we also initialize these pointers, and we also write the 0 byte to the first character in this allocated block. So that means, as before, after this, we always have a 0 terminated string of length 0. Then we can call the append method. As before, it should append a character to the string. So that means it should do the same kung fu as before, if the capacity is sufficient for just adding a character. Well, for this first character, this was obviously the case. Now, if I would append another character, the following should be done by this method. It should reallocate the already allocated block and double the capacity. So each time we have the situation that a character doesn't fit into the current buffer, we just double the capacity. So this sooner or later should be sufficiently large for whatever strings users come up. That means after calling this method again, we would have hopefully a situation like that if realloc succeeds. And then we can add another character and maybe just for fun another, so that you actually see that now we have already 8 characters. If you later call clear string again, it should set back the string to the empty string, and that means you do not release memory here. What you do is you set back the pointers and you initialize the first character in this string with 0, so that we have a 0 terminated string of length 0. And now, of course, you also have to consider where you do all this error handling. You always have to check after a malloc or realloc whether this actually succeeded. Otherwise, you should print an error message and exit with some exit code unequal to 0. And that's actually your homework for the next session.